everyone. I will record a few videos on ANOVA test as well, and also I will record an SPSS tutorial on how to run an ANOVA test. Let's jump into things and get started. So far we have learned that we can conduct a one sample test during which we have one distribution for one sample, right? And we compare the mean of that sample to a test value. So for a one sample T or Z test, we have a distribution for a sample, we find the mean of it, and then compared it to a test value, or we also called that test value hypothesized mean. And this is a value, it's not a sample or a statistic. It's just a value we enter, right? And then in an independent samples T or Z test, we saw that we have two groups on which we collect data. Therefore, we have two distributions, and we compare their means in order to see if they're statistically significantly different. So this is your mean 1, and then this is your mean 2. Your hypothesis is about the population means. mu1 equals mu2 is your null. mu1 does not equal to mu2 is your alternative. And the independent samples test is about these two groups. Actually, let's go ahead and write the null and alternative hypothesis for one sample test too. So it was that your mu equals mu hypothesized, the value, insert the value you're comparing your mean to, right? And then your alternative was that it does not equal your hypothesized mean. This is your null, this is your alternative, this is your null, this is your alternative. After this very brief summary, I just want to say that ANOVA test is measured a little differently than the T or Z statistics that we are calculating, but is theoretically a very, very similar idea to the independent samples test, but we have more than two groups that we are comparing. So once you have more than two groups that you're comparing, then we're gonna go ahead and conduct an ANOVA. And the ANOVA test is going to look if there is any difference between any of the group means. So let's just say I am looking at an example of three groups, three samples here. And so this is your x1, this is your x2, this is your x3. The results for your ANOVA test is going to tell you if there is any difference between any of these means. I will elaborate on that in a second. So after this introduction, let me go ahead and give you a little bit more information about what I'm gonna record in these upcoming several videos. First of all, I will go deeper into ANOVA, and then I will talk about the F ratio because your T value or your Z value does not exist in ANOVA anymore. You have an F ratio that you calculate. So we're gonna calculate an F ratio for an example, and then we'll talk about if you reject the null or fail to reject the null in an ANOVA, what do you do after? Because you actually cannot specifically determine where the difference lies between the groups when you're running an ANOVA test. And then lastly, we'll do some SPSS practice. Alright, so what is an ANOVA? It's a statistical method for examining differences in means of more than two groups. It stands for, actually as a word, analysis of variance. So ANOVA is short for analysis of variances. of the day, I said it's very similar to Z and or T calculation, because at the end of the day, the difference between your means is going to be divided by the dispersion of your groups. We've done this in the independent samples calculation and the one sample test calculation as well. You look at the difference between the means of your groups, and then you standardize that difference with group dispersion. Hypotheses change a little bit for ANOVA. So as you will remember, for the independent samples test, we said that the two group means are different, and then if we reject, we can conclude that the two group means are statistically significantly different. In ANOVA, it's a similar null that we have. We just assume that all of the means that you're looking at for the groups are equal to each other. So mu1 equals mu2 equals mu3. If you have more than 3 groups, 4, 5, 6, you just write all of your group means and equalize them to each other for your null. However, the alternative changes a little bit here, because the alternative hypothesis is just going to be not null. So it's not unequal signs between all your means, because we will reject the null only even if only mu1 and mu2 are not equal to each other and mu2 equals mu3. So if you see something like these are overlapping, but your third group is somewhat distant to the first two groups, then you'll still reject the null. Or if they are the second and third groups that are overlapping are not different, but the first one is different from them, you'll still reject the null. So you will never be able to prove that all of them are different as a result of ANOVA. You will reject the ANOVA also if they are all very different from each other, but you will never know if the scenario is like this, or like this, or like this. You will just know that the null is incorrect. So your null, your alternative, excuse me, this is your null. Your alternative is going to be not null for an ANOVA. And then I also said that in an ANOVA we calculate an F ratio, we do not calculate a T or a Z value. The F ratio conceptually is the variance due to treatment divided by variance due to error. Variance due to treatment is basically another word for variance due to treatment is another word for differences between the means. Because if your treatment is working and the variance due to treatment is high, then let's say you are looking at the means. Let's give the example from last class, red packaging versus blue packaging. If my treatment of red packaging is working and the mean is very high, people really like red packaging, then my variance due to treatment is high. So there will be a higher difference between the means I am looking at. Variance due to error is another name for dispersion within your groups, which is very, very similar to the standard deviation and or variance idea. So variance due to error is basically going to determine how wide or how fat these normal curves for your sample are going to be, your sample distribution is going to be, or how narrow they're going to be, right? So it's very similar to the standard deviation idea, and variance due to error does impact your within group variance. For calculation, we're going to go ahead and actually calculate sums of squares for treatment divided by degrees of freedom for treatment, and then we're going to divide that by sums of squares of error, and then divide that one with degrees of freedom of error. Where I'm going to show you how the calculation is done for sums of squares calculations. However, I do not expect you to hand crank anything during the exam and or any time really during the quiz or during the homework, because we have SPSS for hand cranking these all for us. And I mean, a part of why I'm teaching you guys SPSS is because every researcher usually just chugs everything into SPSS or Excel or another program and gets results from that. However, just so that you guys understand what's going on, I am going to hand crank one example for you in a bit. So this is a vocabulary dictionary kind of what we're going to be doing in calculating an F ratio. Because, let me show you the table. We're going to come up with a table for an ANOVA in order to, at the end of the day, calculate your F ratio. Again, if I give you a table like this and some values are missing from it, I expect you guys to be able to fill out an ANOVA table. And I'm going to go, of course, over how we're going to fill that out. But if I give you raw data, I do not expect you to hand calculate sums of squares for me. Let's go back to the dictionary page. So I will denote sums of squares as SS, degrees of freedom as DF, mean square, which is anything SS divided by DF for you, as MS, treatment, between groups as BG, this is mean differences, remember, and error within groups as WG, and this is dispersion within group, remember. So this is just a little example of, you know, if we have groups that are super close to each other in terms of your means, your F ratio is going to be small in calculation. However, if there is some difference between the means of the groups, then your F ratio is going to come out as high. So this is an ANOVA table guidance tool for you all. I'm going to refer to this when I am doing the example, hand cranking the example in the next page. And whenever you're filling out an ANOVA table, you are given, or you hand crank these two here, which is sums of squares between groups due to treatment, sums of squares within groups, variation due to error. These two, total variation is basically SSBG plus SSWG. So your last row in an ANOVA table, SS total, is always equal to SSWG and SSBG. Let me actually just write those things for you here so you have a copy of them. So SS total is always equal to SSBG plus SSWG. That refers to your first column SS. Similarly, for DF, degrees of freedom calculation, your DF total is always equal to DFBG, degrees of freedom between groups, and DFWG. And then your, actually these are here for you, right, like in the box. MSBG is always dividing SSBG with the degrees of freedom between groups. So whenever you're trying to calculate mean squares, you're going to take the sums of squares divided by degrees of freedom for that groups. Similarly, for means of squares within groups, you're going to take sums of squares within groups and divide it by degrees of freedom within groups. And then lastly, in the last step, your F is going to be this box divided by this box. So mean squares between groups divided by mean squares within groups. So now let's go ahead and hand crank and learn through this example. My example is a marketer from the Colgate Toothbrushes marketing department studies the teeth brushing time of kids with Mickey Mouse pattern brushes, Frozen pattern brushes, and Pink Panther themed brushes. She needs your help with analyzing the following data to find out if different patterns of toothbrushes make a significant impact on teeth brushing time. So basically, are these groups statistically significantly different from each other? Is there any difference between the data groups that I have?